Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be going over Unit 2, Notes 4. So we're going to talk about solving systems using substitution. So let's go ahead and let's just get a jump start on it. So here are the steps, and I always think it's really important that you jot those steps down because having those steps there helps you when you get stuck. Okay, so feel free to pause it and write it down if you need to. Number one, so for number one, we're going to solve one of the equations for one of the variables. You're just going to pick an equation, solve for that variable. Step number two is substitute that expression into the other equation. So I like to phrase this as a substitute teacher. Now, if I were to have a substitute teacher in my classroom, would I be here? No. So we're going to take that and we're going to completely replace what is there, similar to a substitute teacher replacing me. For step number three, you at this point should only have one letter or one variable. So you're going to solve for that remaining variable. Last but not least, you're going to substitute that value into either equation, and then you're going to solve for that remaining variable. Okay, so let's take a look at some of these options. Now, you probably have gotten to know this a little bit on when we worked with elimination a little bit, but I just kind of wanted to make sure I took the chance to write it out for you. So what does infinitely many solutions actually mean? Well, infinitely many solution is if both the variables cancel out and what is left is a true statement. So if it says 7 is equal to 7 or 9 is equal to 9, those are true statements. So that means that it has infinitely many solutions. Now, if it says that it has no solution, so that means both of your variables are going to cancel out, and what is left is going to be a false statement. So if it says 6 is equal to negative 2 or 8 is equal to 3, those are considered false statements. So let's go ahead and let's try solving via some substitution. Okay, so let's start with this one. So here I see that this is already solved for x. So immediately I can go through, and this is skip to step number 2. So since x is equal to this, I'm going to take this and I'm going to plug it in where I see x, okay? So I'm going to remove that x completely and I'm going to put 2y plus 36 in instead. Now, the rest of the equation is going to stay the same. Plus 2y is equal to 8. So now I need to combine like terms. So I have 2y plus 2y. Well, that's going to give me 4y. Plus 36 is equal to 8. So now I need to get that 36 over to the other side. So I'm going to go ahead and subtract 36 from both sides. So then I get that 4y is equal to a negative 28. So now I'm going to solve that for y. Divide both sides by 4, and I get that y is equal to negative 7. So now I know that y is equal to negative 7. So I know what y is. So now I have a choice. I can plug that in for y here, or I can plug it in for y here. Now to me, it makes more sense to plug it in to this bottom equation. It makes more sense because it's already solved for x. So I'm just going to do x is equal to 2. And now instead of the y, I'm going to put negative 7, and then I'm going to do plus 36. It's being crabby with me, isn't it? 36. Okay, so 2 times negative 7 is a negative 14 plus 36. Well, 36 minus 14 is going to give me 22. So then my answer here is 22 negative 7. That is a terrible 2. I don't know what my handwriting is today. Remember, we're going to do x and then y, okay? So now let's go ahead and let's take a look at number 2. Now you may look at this and say, hey, I can use elimination really easily on this question. And just so you guys know, substitution and elimination, you can use both methods, but I think it's important to practice both. So what I'm going to start with number 2 is I'm going to figure out what letter is easy to solve for. So any letter that has a 1 in front of it that's positive is going to be easy to solve for. So I'm going to go ahead and solve for this guy right here. So I have 1x plus 2y is equal to 15. So now I'm going to solve for that x. So I need to bring that 2y over to the other side. Okay, so when I do that, I get x is equal to negative 2y plus 15. Now I can't add those points together because they are, one has a y and one doesn't. So now I know that x is equal to this. So I'm going to go ahead and plug it in for x in the other equation. So notice how I put it in the top equation, not the second equation. So now I'm going to go ahead and I'm going to do that substitution. Okay, so I'm going to take out the 2. I'm going to keep the 2 in, and then I'm going to put this in instead of my x. So I have negative 2y plus 15, or is it minus? Yes, minus 3y is equal to 2. So now all I have to do is I just have to do some distributing. So I'm going to start by doing this, and I'm just really solving for y. So I get 4y plus 15 minus 3y is equal to 2. So I'm going to go ahead and finish solving this over on this side over here, okay? So then negative 3y minus, or negative 4y minus 3y, well, that's going to give me negative 7y. 2 times 15 is going to give me a positive 30, and that's going to be equal to 2. So now I'm going to go ahead and subtract 30 from both sides. So I get negative 7y is equal to, oops, I need a y there, is equal to a negative 28. So now I'm going to divide both sides by negative 7, and here I end up getting that y is equal to a positive 4. Okay, so y is equal to a positive 4. Now I have a choice, okay? I can plug the y in. I can plug it in for this y here, this y here, or I can even plug it into my new version. And I think I'm actually going to use that new version I made, and the reason being is that that equation itself is already solved for x. So then I get x is equal to negative 2, and then I know that y is 4, so I'm going to take that y out and put a 4 in instead. And then I have plus 15. So negative 8 plus 15, so then I end up getting 7. So then I'm going to write that out as a coordinate point. First my x, and then for some reason my 4's look like y's, then my y. All right, taking a look now at number 3. So for number 3, what we're going to do is we need to solve this for a letter. So again, I always want to look at what's my easiest letter to solve for. So we're going to start with this one right here. Well, to me, it looks easiest to solve for x in this one because that x already has a 1 with it. If you were to solve that one for y, you would end up getting decimals when you divide it by 7. And I just like avoiding decimals. So then I'm going to take x minus 3y and set that equal to 0. So I'm going to go ahead here and add 3y to both sides. So then I end up getting that x is equal to 3y. So I'm going to take that 3y and I need to substitute it in for y up there. So now I'm going to go ahead and do that. So everything else in the equation is going to stay the exact same. However, instead of writing that y, I'm going to plug it in for x. Goodness, that was my mistake. Since it's equal to x, we need to substitute it in for x. I'm sorry if I confused you. So the y needs to stay in there. We have x is equal to, so I need to substitute it in x. So whatever your variable is equal to, that's what you're going to substitute it in for in the original problem. So if that confused you, feel free to come back and let me know. So I'm going to keep everything in the equation the same, except I'm going to take out the x and I'm going to put 3y in instead. So if you did the substitution right, you should only have one of each, or you should only have one letter left in your equation. So I have 7y is equal to 26, and then 11 times 3 is 33y. So now I need to get my y's on the same side, so I'm going to go ahead and subtract 33y from both sides. So 7 minus 33, that's going to give us a negative 26y, and that's going to be equal to a positive 26. So I'm going to divide both sides by a negative 26, and that's going to give me that y is equal to a negative 1. So now I know that what y is equal to. Since I know what y is equal to, I can plug it in here, here, or here. Well, this equation right here is already solved for x. So I'm going to go ahead and put my y in there. So I'm going to take out the y and I'm going to put in negative 1 instead. So then I end up getting that x is equal to negative 3. So now I need to write that out as a coordinate point. So first I have my x and then I have my y. So that's my answer right there. Now, oops, I forgot number 4. So let's go ahead, we're going to erase this and take a look at number 4. So for number 4, one of the first things I notice is that it's already solved for y. In fact, both of them are solved for y. So let's go ahead and let's take a look at number 4. So since they're both solved for y, we're just going to kind of still do substitution, but it's going to end up looking a little different. So y is equal to this, so I need to substitute it into the y up above. So then when I substitute that in on that side, I'm going to get 4 plus x is equal to 3x minus 4. So the first thing I want to do is get my x's on the same side. So what I'm going to do is I'm going to take this positive x and I'm going to subtract it over to the other side. You could bring the 3x over if you wanted to, but you don't have to. So then here I get 2x and then minus 4. So now we're going to add 4 to both sides. Okay, I'm trying to get that x by itself. So here I get 8, and that's going to be equal to 2x. So I'm going to divide both sides by 2, and then I get that x is equal to 4. So now I know that that's what x is equal to, so I can plug it in for this x here or that x there. It doesn't really matter. So let's just plug it into the bottom one just for fun. So I'm going to keep everything else in the equation the same, except instead of writing x, I'm going to write what x equals, which is 4. Okay, so x is equal to 4. So then now y is equal to 4 plus 4, which is 8. Now if you had plugged it into this top equation, you would have gotten the exact same answer. If not, then you did something wrong. So then I have 4, 8 as my solution for number 4. Let's take a look at 5 and 6. So taking a look at number 5 to start off with, okay? So we have number 5, and it's almost already solved for x. So actually what I'm going to do is I notice that I can divide both sides by 2, and it will be solved for x. So when I do that, I get that x is equal to 2y plus 2. So now I know that x is equal to 2y plus 2. So where I see x up here, I'm going to remove that x completely, and I'm going to put in 2y plus 2 instead. So I'm going to have the 3, I take that out, and then I get 2y plus 2. Now the rest of the equation is going to stay the exact same, like so. So then I'm going to distribute in that 3. 3 times 2 is 6y. 3 times 2 is going to be 6. And then minus 6y is equal to 6. So those, I notice, are going to cancel out. Then what I end up getting is 6 is equal to 6. Well, that right there is a true statement. So since they all canceled out and it's a true statement, that means that I'm going to have infinitely many solutions, which we in the past have abbreviated as IMS. So IMS is your final answer for number 5. Okay, so now let's go ahead and we're going to take a look at number 6. Okay, so let's take a look at number 6 now. So for me, I think a lot of students look at this and they immediately want to divide both sides by 2 here. But again, that's going to give you a fraction. So I am going to solve for a variable, but this time what I'm going to do is I'm actually going to solve for y. So I'm going to subtract 7 from both sides. So I get 2x minus 7 is equal to y. So now I know that 2x minus 7 is equal to y. So I see y up there. I can go ahead and plug that in. So let's go ahead and let's do that. So I'm going to have 6x minus 3, and in parentheses I'm going to have 2x minus 7. Okay, and then that's going to be equal to 24. So now I need to distribute. So the 6x is going to stay the same. 3 times 2x is going to give me a minus 6x. 3 times a negative 7 is going to give me a positive 21. And that's going to be equal to 24. Well, 6x minus 6x is going to cancel out. So again, all of our letters canceled out. All of our variables canceled out. And what I'm left with is negative 21 is equal to 24. I'm sorry, positive 21 is equal to 24. Is that ever going to be true? No. So since that's not going to be true, our answer is no solution. So what I'm going to do is I'm going to go ahead and stop the video right now. I want you to go to your worksheet and just do some practice substitution problems. Then when that's done, you can come back and we'll go through some word problems. So I want you to practice substitution first, and then we'll come back and do the word problems in the second part of this video. Thanks for listening.